Hi guys, it's me, Da Vinci Decode. In this video, I'm gonna talk about a story of one of the most brilliant minds to walk on this planet, Galileo Galilei. Galileo is famous for being the father of science, astronomer, philosopher, and mathematician, who made fundamental contributions to the study of motion, mathematics, astronomy, and the development of the scientific methods. His formulation on the circulation inertia and parabolic trajectory marked the beginning of the fundamental change in the study of motion.
He is often considered the father of modern science.
Galileo was the one who really put together the principles of experiment, theory, and mathematics together into a common framework.
Probably more than anyone else, Galileo was really the person responsible for developing modern astronomy.
Galileo first gained fame when he discovered what is now called the law of the pendulum.
One day in the cathedral, he was watching the lamps that were hanging from the ceiling and saw them swaying back and forth, and started thinking about the nature of a pendulum.
He found that the amplitude of the swing doesn't matter, but the length of the pendulum does. And this became the genesis of regulation of clocks, for which he became instantly famous.
Galileo also gained fame by supposedly using the Leaning Tower of Pisa to prove the law of constant acceleration.
It's said that Galileo dropped two steel balls of different masses but the same material from the Leaning Tower of Pisa, and they landed at the same time, in contrast to what Aristotle would have predicted.
What's important about this is not only the result, but the fact that he ushered in this new method of doing science, where you conduct an experiment to test a hypothesis. He showed that you have to do more than just think something's true, you have to prove it.
Galileo was born on February 15, 1564, on Paris, Tuscany, Italy.
He was the first of 6 children to Vincenzo da Bonajuti di Galilei and Guido Galilei. The Galileis, they were from an ancient and respected family who originated in Florence. At the age of 4 days, young Galileo was baptized Catholic. He was raised according to the strict tenets of the faith, as was everybody else in the region. From an early age, Galileo showed an intense interest in making things. He was constantly making small little gadgets that would amuse his friends and his teachers. These would include wooden animals with moving arms and legs. He was fascinated by how machines worked and had been constantly pulling things apart and then putting them back together again. If he was making a machine himself and he didn't have a part, he'd simply improvise. When Galileo was 10 years of age, his father decided to move the family to Florence. By now, Vincenzo had developed a reputation as a learned and wise man. Despite the demands of business, he managed to write several books, the most popular of which was the Dialogue of Ancient and Modern Music.
And in 1581, he matriculated to move to the University of Pisa, where he was immersed in mathematics, philosophy, and
Galileo
astronomy.
passed the bachelor's exam, which permitted him entry to the University of Pisa. Universities in the 16th century, they were places attended by members of only the wealthiest families and were generally reserved for those with the ambition of becoming a priest, a doctor, or a professor. Although Galileo seriously considered the priesthood as a young man, Galileo, or more likely Galileo's father, had decided on a career in medicine for him. In order to achieve it, he first had to obtain a master's degree. Galileo applied himself to his studies and made excellent progress. However, several months into the first year of his medical degree, he happened to overhear a geometry lecture being delivered by a friend of his father, Ostilio Ricci. He was immediately attracted to the logic and beauty of the math that was being applied. When Ricci heard from Galileo's father that the boy was fascinated with his lecture, he invited him to take his course. Vincenzo had first made Ricci promise not to let Galileo know that he had consented to him taking the geometry paper in case he saw it as permission to abandon his medical studies. In addition to attending geometry lectures, Galileo worked one-on-one with Ricci as he studied the works of the Greek mathematician Euclid. As he became more deeply immersed in the subject, Galileo became less interested in medicine. Finally, he confronted his father and asked him not to stand in the way of his focus on geometry. Vincenzo, he was a realist. He knew that his son would not prosper as a doctor if his heart wasn't in it. He agreed to support Galileo in his mathematical pursuits.
So Galileo decided to make his profession. He prepared to study Aristotelian philosophy and mathematics. In 1609, Galileo heard that the Netherlands are inventing a new instrument that helps the user to seek and see far and distant things and as thought they were near. Galileo wants that instrument for scientific purposes. So, he replicated and tried to improve it to its full potential. By trial and error, he succeeded, and now he has an 8-powered telescope. With that such a powerful telescope, he began searching the heavens.
Of strength that one could take the weakest convex lens and combine it with the strongest concave lens and get an appreciable magnifying effect.
Galileo set out to turn the Dutchman's toy into a useful device.
Hearing reports of a new invention from a lens maker in Holland, I determined to fashion a device for myself and was able to make considerable improvements in it.
Galileo realized that spectacle makers could not give him the lenses that he needed in order to make this device more powerful. They just weren't good enough, and they weren't the right strength. And so, in order to improve the instrument, he had to teach himself to grind lenses. And that is extremely difficult, and it certainly was in 1610.
At first, Galileo was only interested in the optics of the telescope. With his improved lenses, he increased its power tenfold. But his lenses did more than magnify. By reshaping these pieces of glass, Galileo would eventually reshape our view of the world. With his telescope, Galileo first set out to make some money. The naval arsenal of Venice was the greatest in all of Europe. What if the arsenal had a way to spot enemy ships hours before they appeared in the harbor? Wouldn't this give the Navy a distinct advantage? Installing his new device at the top of St. Mark's Tower, Galileo arranged persuasive, real-life demonstrations.
Numerous gentlemen and senators more than once climbed the stairs of the highest bell towers of Venice to observe vessels so far away at sea that 2 hours and more were required before they could be seen by naked eye without my spyglass.
From within the Venetian Senate came a handsome order for Galileo to supply the arsenal with spyglasses. Galileo was given a generous lifetime salary for his service to the Republic. Part scientist and part self-promoter, for now, his future seemed bright.
In the fall of 1609, he drew the phases of the moon.
Galileo's daughter was just 9 years old on a November night in 1609. That was the evening when Galileo first pointed his new spyglass at the moon setting behind the hills of Padua and began to sketch what he observed. It was the start of 8 weeks of sleepless nights spent in his tiny courtyard, suddenly transformed into the world's premier astronomical observatory.
From my observations, I have been led to the opinion that the surface of the moon is not smooth, uniform, as a great number of philosophers believe it and the other heavenly bodies to be, but is uneven, rough, and full of cavities and prominences, being not unlike the face of the earth, relieved by chains of mountains and deep valleys.
The moon Galileo saw was Earth-like, and he sketched its features with Earth-like detail. If the surface of a heavenly body resembled the Earth, perhaps the heavens and Earth were not as different as everyone thought.
Galileo had observed the moon through a series of phases, and he apparently made some adaptations to his instrument and began exploring the planets.
In the early January of 1611, he discovers the 4 famous moons of Jupiter.
Now, Jupiter was the one that was in the most favorable position for observation. It was closest to the Earth at that particular point. And when Galileo looked at Jupiter, he saw 3 very bright little stars, invisible with the naked eye, on a line with Jupiter. And he remarked on that. He had no idea what they were. I mean, he thought that, of course, they were what they used to call fixed stars. In other words, the things that we call stars. But then, since it's such a remarkable configuration, he came back to it the next night. And, well, yes, there were still 3 stars, but their relative position to Jupiter had changed. And so within a week, he realized that what we have here are moons of Jupiter. Like the moon goes around the Earth, these moons go around Jupiter, and there are 4 of them.
4 planets, never seen from the beginning of the world, right up to our present day. These wandering little stars make their journeys around the planet Jupiter with a marvelous speed and with mutually different motions, like children of the same family.
In a little more than a week, Galileo had found the first new astronomical bodies to be discovered since ancient times. This discovery clashed with the common belief that the heavens revolved around the Earth alone. Eventually, it would bring him head-to-head with church dogma. But for now, Galileo was exuberant.
He rushed into print because he knew he could get scooped. If we date the discovery from the first observation of Jupiter's satellites until he realized they were moons, January the 7th to January the 15th, he was in print by March the 12th. The book was out.
Sidereus Nuncius, the starry messenger, was an enthusiastic announcement of telescopic astronomy. The first printing sold out within days, and news spread across Europe of Galileo and his amazing telescope. Galileo became an advocate for his new astronomy.
Galileo approved Nicholas Copernicus' theory that the sun is the center of the solar system and not the Earth, and that the Earth is just several planets orbiting it.
Galileo's was becoming more comfortable and secure enough to take a risk, even in the doctrinaire atmosphere of Florence. Galileo adopted the view that Copernicus was right. The sun, not the Earth, was the center of our planetary system. Months passed as he struggled for a way to prove it.
For him, demonstration was the mark of science. For something to count as a scientific claim, it had to be demonstrated. It had to be conclusively shown to be the case. Anything short of that was called conjecture or opinion.
To the naked eye, Venus was just a point of light. But through his telescope, Galileo saw the planet as a disk. Over a period of months, Venus changed from a small disk to a larger crescent. Galileo immediately grasped that in a sun-centered system, this crescent would appear as Venus circled in an orbit between the sun and the Earth. Venus must be revolving around the sun rather than the Earth. But the argument was just beginning, and Galileo utterly misjudged the opposition. Opportunistic priests in Florence announced from their pulpits that Galileo was spouting dangerous new ideas. A chorus of jealous academics, bruised by Galileo's arrogance, joined the clamor. Galileo counted on his Medici patrons to protect him, but that protection started to erode when the Grand Duke Cosimo's mother began to have doubts. Galileo had named the moons of Jupiter for the Medici family, but the Grand Duchess questioned their authenticity.
Are they real? Oh yes, said Castelli, even the Jesuits down in Rome have confirmed this. And then she switched the subject. She said, what about Copernicus? And what about Joshua at the Battle of Gibeon, when he commanded the sun and not the earth to stand still?
In the book of Joshua, the Lord halts the movement of the sun, allowing the Israelites a bit more daylight to defeat their enemies. This and a half dozen other biblical passages seem to suggest that it was the sun which moved, not the earth. The Grand Duchess Christina worried that her new court philosopher was contradicting the Bible. Galileo answered Madama Christina with a letter that went far beyond astronomy.
Galileo was honest when he said that if the Bible seemed to say something different from what science said, then you had just misinterpreted the Bible.
Galileo's outspoken letter to Madama Christina, intended to resolve the discrepancies between science and the Bible, came to be seen as an assault on the Bible itself.
And that letter gets circulated, and local priests read it, and they're outraged, and they're sending copies to Rome, and they're saying to people at the Inquisition, you should investigate Galileo, you should do something about this guy's a heretic.
Galileo surely knew what could happen to heretics when the cardinals of the Inquisition organized to purify society by combating heresy. Much of their work was the banning of books, but the Inquisition also had the powers of both torture and execution. Rome's dungeons had seen the end of many heretics, including the infamous Giordano Bruno, fallen priest and occult dabbler in science. To the Inquisition, extreme measures were justified. Whatever pain was inflicted to save the soul of a heretic was nothing compared to the pain of eternal damnation.
One of the things that the papacy wants to show to a united Europe, Catholics above all, is that there's no tolerance for dissent, that dissent will be rooted out and punished. A Scottish heretic is burned at the stake with a pitch shirt so that he'll burn all the more brightly. And Bruno, who's burned alive, which is quite unusual. Most people are burned when corpses, is one of a whole series of people who are put to death as a way of showing that orthodoxy will be enforced.
Giordano Bruno was a priest and a New Age charlatan who denied the divinity of Christ. But like Galileo, he had described a vision of the universe which had the earth spinning around the sun.
There's been a lot of different views as to how much the Bruno parallel weighed on Galileo. Undoubtedly, it must have had some influence. He realized, of course, what had happened to Bruno. I doubt if he thought himself to be in danger of that, but at the same time, there was that looming thing in the background that if he defied the Inquisition here, he could suffer very severe penalties.
Behind Bruno's execution was Rome's greatest inquisitor, the hammer of heretics, Roberto Cardinal Bellarmine. Now, years later, this same Cardinal Bellarmine was receiving reports about Galileo.
Church theologians have been alert to the possible implications of what Galileo is doing. And there is slowly somewhat of a Galileo file building in Rome, in the Inquisition. And as these noises coming from the lower tier of the clergy in Florence become louder and louder and louder in Rome, Galileo goes to Rome to try to argue his case.
Galileo actually welcomed the chance to make his case to Cardinal Bellarmine. He had heard that Bellarmine had an interest in astronomy and was fascinated by the telescope.
Bellarmine himself, who began interested in science, as he progressed in science, realized that there were a number of aspects to scientific discovery that threatened orthodoxy as he saw it, and realized that science might interfere with his theology, and decided at that point to shut down his scientific investigations. And he made a personal choice to opt for piety rather than scientific curiosity, which never, I think, is a completely satisfactory solution. And it may explain some of his virulence in going after what he perceives as scientific heresy.
The vote was 11-0. The hypothesis that the Earth moved was foolish and absurd. The belief that the sun was the center of the world was a matter of formal heresy. Cardinal Bellarmine would use his meeting with Galileo to deliver the edict.
Galileo will be told formally not to hold and defend the Copernican position. And what's more, in the decision it is stated that should Galileo refuse this order, he will be silenced.
Galileo is forced to turn his back on Copernicus, whose work is added to the index of prohibited books. But instead, matters had become much worse. With the stroke of a quill, the Church had banned Copernicus and, for now, muzzled Italy's greatest scientist. If there were to be a struggle between religion and science, religion had won the first round.
Galileo was a good Catholic, so he had no interest in fighting the Church. What he was about from the very beginning of his public support of Copernicus was to bring the Church to an understanding of the theory and of the theory's complete lack of threat to the Church. If the Church struck a defensive posture about something that looked like it had a very good chance of being true in fact, the Church would face embarrassment.
Galileo vented his frustration in outspoken letters to close friends and supporters.
To ban Copernicus, when his doctrine is daily reinforced with many new observations, seems, in my judgment, to be a contravention of the truth, hiding and suppressing her when she's most clearly and plainly revealed. Despite the advances of Copernicus, within his theory are couched mystery so sublime and concepts so profound that hundreds and hundreds of the most acute minds have still not pierced them.
Cardinal Bellarmine may have slammed the door on Copernicus, but his philosophy left one small opening for Galileo to seize upon.
Cardinal Bellarmine had argued that the Church can change its opinion, but only if there is real proof that the Earth goes around the sun.
The Church did not accept Galileo's claim that the phases of Venus proved a sun-centered universe, so he set out to find physical proof that the Earth was moving. From his younger days in Venice, where the water level could rise or fall many feet in a day, Galileo had developed an interest in the tides. Just as water sloshes back and forth in a swinging container, Galileo reasoned that the Earth, as a giant vessel spinning on its axis, might cause the seas to rise and fall twice a day. He believed that the tidal motions of a body of water like the Mediterranean might offer proof that the Earth moved.
To make the water contained in the basin of the Mediterranean behave as it does surpasses my imagination, and perhaps that of anyone else who enters more than superficially into these reflections. Some say Aristotle, after observing the tides for a long time from some cliffs, plunged into the sea in a fit of despair and willfully destroyed himself for the mystery of them.
Up to this point, he's been very bold. In 1616, he had in fact circulated, given to some cardinals, a tract on the tides in which he argued that this is actual physical proof that the Earth moves.
If, like a galloping steed, the Earth is hurtling through space, why can't we feel the movement? Galileo seized on the paradox that the Earth could spin on its axis fast enough to cause day and night without people sensing the motion.
What is really exciting about Galileo, and you see it exactly the same in Einstein too, was the way he picked up what seemed to be an absolute impossibility. He said, we have this incredibly strong evidence that the Earth is not moving. Everything that our senses tell us is that the Earth is not moving. And yet Copernicus has got these rather strong arguments from astronomy to suggest that the Earth is moving. So then Galileo says, well, this actually should tell us something very deep about how nature works.
So he devised an intriguing thought experiment. He used a horse to represent the motion of the Earth. If a rider dropped a ball while standing still, the ball would, of course, fall straight down, landing beside the horse. But what would happen if the same rider dropped the ball with the horse at full gallop? In Galileo's experiment, the forward motion of the horse would be communicated to the ball through the rider's hand. As the ball dropped, it would continue to move forward and would still land beside the horse, just as it had done when the horse stood still. To Galileo, when the horse and the ball shared the same motion, it was as if the motion did not exist. If the Earth were moving, could we be carried along with it and not be conscious of its motion?
There is a sort of a principle of relativity where if you're sort of moving with the Earth, everything shares the same motion. Not only is the Earth moving, but I'm sharing that motion as well. And therefore it is all hidden. It was probably the first really great thought experiment in physics. In fact, he was so confident of the result, he never even bothered to do the experiment to show it was right.
Despite his troubles with the Church, Galileo was still well supported by the Medicis. Even on the bright surface of the sun itself, Galileo observed dark blemishes, which he named sunspots. He could not have known that the spots were actually magnetic storms, but his descriptions of them were remarkably accurate.
Sunspots are generated and decay in longer and shorter periods. Some condense and others greatly expand from day to day. They change their shapes, and some are most irregular. They must be enormous in bulk, being either on the sun or very close to it.
Galileo gets into an argument with a German Jesuit mathematician named Christoph Scheiner about the nature of sunspots. The German argues that these spots are in fact little satellites that go around the sun. Whereas Galileo argues that these spots are really either on the surface of the sun or very close to it, and that they're sort of like perhaps clouds.
If the Jesuit were right, and the spots were independent satellites, then the surface of the sun would remain pristine, as doctrine demanded.
Sunspots have a very irregular appearance, and if you can bring that out visually, then the argument that these are satellites of the sun becomes absurd. And so Galileo very carefully planned the publication of his letters of sunspots. They're all oriented properly so that you can see them from one day to the next, being sort of born on the sun and dying there. All of a sudden, in the middle of the sun, appears on one day a little spot, and the next day it grows, and then it grows some more, and then it slowly goes off the edge. Clearly, there are spots on the sun that are so irregularly shaped that they can't possibly be satellites. There is a visual essay in which you have uninterrupted views of sunspots.
Galileo produced a series of intricate engravings recording the daily changes of his sunspots. the continuous movements of the blemishes suggested that the sun might actually rotate on its axis.
The visual evidence is accepted by both Copernicans and people who still believe that the Earth is the center of the universe. But it is the interpretation of that evidence. And more and more and more, you see these conservative astronomers then stretching. Because if you can say that these are satellites of the sun, you can still say that the sun is perfect.
Galileo knew that his adversaries were wrong. It didn't matter if the Jesuit mathematician wished the sun to be unblemished. Galileo had demonstrated real spots on the surface of the real sun.
But Galileo was arrested, accused, and opposed church teaching. And the punishment is death or lifetime imprisonment. But because of Galileo's old and weak body, he was just sentenced for house arrest for the entire day of his life. But Galileo didn't give up. He proved that the comets and the tides were the evidence for this. No one listened to him.
And often confined to his bed, Galileo began to re-examine his own early work. Forced to avoid astronomy, Galileo looked back to a time before his telescope, to his brilliant but never published research on the physics of motion. Galileo had spent half a lifetime trying to prove the Earth moves. Now, he would come to terms with something much more basic, the mathematics of motion itself. But motion is hard to measure.
It all happens just a bit too fast for you to see what is going on.
Galileo reasoned that as balls rolled down slopes, they would accelerate, just as they did in free fall, but more slowly. As a young man, Galileo had designed a very accurate inclined plane, one of the most important pieces of experimental apparatus in the history of science. Galileo left behind no plans for his inclined plane, but based on his experimental notes, Professor Roberto Caparelli is using what he believes to be Galileo's original design to discover how he was able to accurately measure acceleration.
Galileo
studied the inclined plane, slowing the motion of falling bodies until he was able to observe the phenomena. He was able to measure exactly how fast a ball would roll, timed with the swing of a pendulum. Galileo was sure that the steady acceleration must be governed by a mathematical rule.
Galileo had found a mathematical rule for accurately predicting the motion of objects in the real world, a universal law which applied to any falling bodies. As a young man, Galileo had revolutionized astronomy, but at the age of 74, his last great book revolutionized the physics of motion.
From the point of view of physics, his most important contribution is his discourse on the two new sciences. Indeed, it's that book that provides the real foundation for Isaac Newton.
Within a generation, Newton had built on Galileo's work to devise a set of laws so complete that they could describe the motion of the planets in their orbits and how apples fall from trees.
Until his death on 1642, Galileo's life was incredible and fascinating, but yet unfair.
Galileo's final years were marked by ill health. By 1637, he was nearly totally blind. Before his sight was gone completely, he managed to complete his last and, in his view, his most outstanding work, entitled Discourses and Mathematical Demonstrations of Two New Sciences. Under the rules of his sentence, he could not publish it in Italy, and so the manuscript was smuggled to Amsterdam and published there. During his last days, the blind genius received many visitors to his villa. He died on January the 8th, 1642, at the age of 77. He had been fighting fever and heart problems for months. Nearly 100 years later, with his brilliance having finally been recognized, his remains were removed from the chapel at Santa Croce and relocated to a much more elaborate mausoleum inside the church. During this move, 3 fingers and a tooth were removed from his remains. One of these fingers, the middle finger from Galileo's right hand, is currently on exhibition at the Museo Galileo in Florence, Italy. A monument was also erected with a bust of Galileo and 2 figures representing his monumental achievements in the worlds of astronomy and geometry.
The moral lesson for this video is that don't always believe in what you heard or what someone says before you believe. Always search for important information that would allow that conspiracy to be true, for you to be sure that what people believe was true. In short terms, don't be
The Catholic Church
gullible.
admitted that it had been wrong to condemn Galileo Galilei for promoting the Copernican astronomical theory. After a 13-year investigation into the persecution of Galileo that led to his official condemnation in 1633, Pope John Paul II rectified a wrong that forced the Italian astronomer and physicist to live the last years of his life in exile, and worse yet, to recant his proven discoveries to save his hide. Since then, the Church has taken several steps to reverse its stance against Galileo's finding prior to the action in 1992. Galileo's dialogue concerning the 2 chief world systems was stricken from the Index, a list of banned publications, in 1757. A preliminary report conducted in 1984 by scientists, theologians, and historians summarized that Galileo had been falsely condemned. Pope John Paul II concluded he had been imprudently opposed. The leader of the investigation, conducted in 1992, Cardinal Paul Poppard, said, "We today know that Galileo was right in adopting the Copernican astronomical theory," a statement that would have put him at risk of being arrested and possibly executed by his own church just a few hundred years previously. Pope John Paul II himself noted that the whole business was a rather tragic mutual incomprehension, and that the new science, with its methods and the freedom of research which they implied, obliged theologians to examine their own criteria of scriptural interpretation. Most of them did not know how to do so. Paradoxically, Galileo, a sincere believer, showed himself to be more perceptive in this regard than the theologians who opposed him. "If scripture cannot err," he wrote to Benedetto Castelli, "certain of its interpreters and commenters can and do so in many ways. From the Galileo affair, we can learn a lesson which remains valid in relation to similar situations which occur today and which may occur in the future."
And then all the way forward into 1992, Pope John Paul II, who I believe is the man pictured here on the right, regretted the Church's errors in regard to Galileo. He admitted that it had been wrong to turn astronomy into a matter of religion. So obviously he couldn't apologize to Galileo. It had been, hundreds of years since he had passed away, but he did publicly basically state that the Church had been wrong, and that they as the Catholic Church in general, they regretted the way they had handled the situation, and that it had been wrong to turn astronomy into a matter of religion. And this is just what Galileo had stated 350 years before that.
Well, thank you for watching this video. I really hope you enjoy. Bye!